spectroscopy is an analytical method that measures the amount of light a sample absorbs in the ultraviolet, UV, and visible, VIS, regions of the electromagnetic spectrum, providing data on the sample's chemical composition and concentration. This technique uses a spectrophotometer to pass light through a sample and measure the absorbed wavelengths, with the results forming a unique spectrum or fingerprint for the substance. UV-VIS spectroscopy is widely used for quantitative analysis, identification of functional groups, and monitoring reaction kinetics, relying on Beer's law to relate absorbance to concentration. How it works. 1. Light source. A light source, such as a xenon lamp, emits light across the UV and visible spectrum. 2. Wavelength selection. A monochromator or prism separates the broad spectrum of light into its individual wavelengths. 3. Sample exposure. The selected wavelength of light passes through a sample held in a cuvette. 4. Absorption. Molecules in the sample absorb light of specific wavelengths, causing their electrons to jump from a lower to a higher energy state. 5. Detection. A detector measures the amount of light that passes through the sample and reaches it. And 6. Spectrum creation. The instrument records the amount of light absorbed at each wavelength, producing a UV-VIS spectrum. Key principles. Electronic transitions. UV-VIS spectroscopy is based on the principle that molecules absorb UV and visible light energy, causing electrons to move to higher energy levels. Beer-Lambert law. This law establishes a linear relationship between the absorbance of light and the concentration of the analyte in the sample. The formula is typically expressed as A equals epsilon Bc, where A is absorbance, epsilon is the molar absorptivity, a constant for a given substance, B is the path length of the light through the sample, and C is the concentration of the analyte. Applications. 1. Quantification. Measuring the concentration of DNA, proteins, or other substances in a solution. 2. Identification. Identifying functional groups within organic and inorganic compounds. 3. Quality control. Assessing the quality of food and beverage products and detecting contaminants. 4. Environmental analysis. Detecting pollutants in water samples. And 5. Kinetics. Monitoring the speed and progress of chemical reactions over time. Equipment. 1. Spectrophotometer. The primary instrument used for UV-VIS spectroscopy. 2. Cuvettes. Small, transparent containers that hold the sample for analysis. 3. Light source. Provides UV and visible light. 4. Monochromator. Selects specific wavelengths of light. And 5. Detector. Measures the intensity of the light after it passes through the sample.